Shalom to you and welcome. In this video, we'll be looking at point of intersection of two lines. When you have more than one equations, like here we have two different equations, so we can solve those equations. They are called system of linear equations. See, each one of them is linear. So there are several ways of solving them. One of them would be graphing. So if you graph each of those function like this one, their point of intersection is the solution. So it is ordered pair. If you see, it is not just one number, it is an ordered pair of x and y where they intersect. So another way of solving it is simultaneously substituting one variable into another. So you need to solve for one of the variables first. Either you solve for x or you solve for y in one equation, and then you substitute in another equation you choose. So we're going to solve this system of equation by substitution. So if you notice in this equation, x has no coefficient, so it might be an easier one to solve. So let's solve for x here and then substitute it into the second equation. So let's get here. Okay, so if we solve for x here, that means we are subtracting. So let's subtract 2y from both sides. Remember, when we add or subtract terms, we only subtract like terms. So here, this will be 0. Negative, positive 2y and negative 2y will be 0. So that is out. And then we are left with y on this side. So here we have, we still have 8 minus 2y. We cannot add 8 and 2y because they are not like terms. Negative 2 has y in it, but 8 does not. So we just keep them separate. They are not like them. So now x is by itself. So, and this expression represents x. So we can actually now substitute this expression for x. So wherever we see x in this equation, we replace that. So let's now go to this equation here. This is x right here. So we replace x with this expression because it is equal to x. So now write everything in that equation, except when we get to x, we just substitute the expression. So we have 3 times x, and instead of x, we put 8 minus 2y. Then we close that parenthesis again. This is just substituting for this x. And then we keep the minus y equals 3. And what this does, it removes one of the variables. So you have only one variable to work with. So now we have only y in our system. So it's easy to. So now we distribute 3 times 8. Okay. So 3 times 8 is 24. And then 3 times negative 2y, watch the sign there, will be negative 6y. And then we still have this minus y, and then we keep the right side. Now we collect like terms. Okay, keep 24. We have negative 6y plus negative y. Again, this you can write it as plus negative 6y plus negative 6y. So you have negative, negative. They are both like terms. So you still have negative 7y. Okay, equals 3. So next, we can either subtract 24 from both sides, or we can add 7y to both sides. Either way, you still get the same thing. So let's add 7y to both sides. That way we can make it positive, because we don't want y to be negative, although even if we have it, we can still undo it later. But okay, so we have 24 plus, so that cancels it here. So we have 24 left on this side is equal to 3 plus 7y. And now we can subtract 3 from both sides, because this is addition. We can subtract 3 from both sides, and then we have 24 minus 3, and we have 21. Oops, hold on, my pen is kind of okay. 21 is equal to, and this goes away, 7y. And now we can divide both sides by 7. We divide both sides by 7, y is going to be 3. Okay, so y is 3, but that's one part of our answer. We still need to find x, but we already solved x here. We just need to put the expression, so we can come back to this and substitute y, substitute 3 for y in this equation to help us find x. So this minus 2y, and instead of y we put 3, and then follow the order of operation. Okay, make sure don't subtract this, make sure you multiply first. So 2 times that is 6, and then finally subtract 8 minus 6 is 2. So we have our x and our y. So our ordered pair solution is going to be, make sure you write x first, 2 comma 3, and that's our final answer. This is where these two equations will intersect. Okay, all right, let's do another one. Find the point of intersection of the two lines. Okay, here if we notice, we could solve for x here, we could solve for any variable or y, but here y is already solved, so that is actually easier. Y is already solved. We can go ahead and substitute this equation into this equation for y. So let's do that. Let me just let's box what we are substituting. So okay, this is the expression that represents y. So under here, we write everything x, and then when we meet y, we just plug in this expression. Instead of y, we do 2x minus 3 equals 4. Okay, now again, follow the order of operation, keep your addition and subtraction. Okay, here we're going to multiply, distribute 2 times 2x is 4x, and then 2 times 3 is, this is, remember, negative. Okay, it's positive times negative is, it's negative 6. So either you write minus 6 or you just, sorry about this. Okay, so we go to, all right, then we keep equals to 4. Now simplify, collect like terms. So we have 4x and 1x here, so that gives us 5x, and then minus 6 equals 4. And then now we can add 6 to both sides. This is normal solving equation. So that's 5x equals 10. So x is going to be, when we divide both sides by 5, we get 2. Okay, so this is x. Yet to find y, and again y is already solved for, so we just substitute 2 for x in here and then find y. So that's 2 times 2 minus minus 3. So again, make sure you follow the order of operation. 2 times 2 is 4, minus 3, so y equals 1. And that's the y. So our solution is going to be in order pair: x first, 2, 1. Alright, and that's our final answer.